Ma'am, Srivacha is coming.
Okay.
Good evening, ma'am.
Good evening, Srivacha. Am I audible?
Yeah, material science. Your pen. Very fast.
Okay. Ready?
Huh?
You are ready? Please confirm whether am I audible or not. You are ready?
Yes.
Okay. So today we are going to start quantum numbers.
Which one?
Quantum numbers.
Madam, which one? Quantum?
Quantum numbers.
Okay.
So it's like important concept. Very, very, very important. Okay. So what's the use of quantum numbers? So why quantum numbers are useful? So why we have to study about quantum numbers? Okay.
Good.
So quantum numbers help us to know about the energy, size, shape, and orientation of an orbital. So what is orbital? First we have to know. So before that, let us discuss what is orbital. What is orbit, Srivatsa? What is an orbit?
Orbit?
Yeah,
Okay, fine. So orbit are like shells.
very good. Shell. How we are going to define an orbit? Orbit is a
The orbit is a
circular,
circle.
yeah, it is a circular path around the nucleus where electrons revolve. Okay, so orbit is circular path around the nucleus where electrons revolve. Okay, so now next. So in an orbit, in the entire circular path, do you find electrons? That's your question. So
Yeah,
if
with the entire circle, you cannot find electron.
yeah, electron will be somewhere. So where the electron is present. So electron is present in an orbital. So next definition you have to know is an orbital. So what is orbital? Orbital is the place where you can find, like where probability of finding an electron is maximum. Okay, the
Yeah.
space around the nucleus where probability of finding an electron is maximum. Mostly like 90 to 95% you can find an electron in an orbital. Okay,
Yeah. Yeah.
clear?
Yeah.
Okay, so before learning about the quantum numbers, I think it's better you learn about an orbital and types of. Okay,
Yeah.
so can you please read the definitions? What is orbit and what is orbital? Go ahead.
You can understand.
Okay.
Reading.
Orbit is a circular path around the nucleus where electrons revolve.
Hey,
So
your
orbit,
energy is looking low. Seems low. What happened? No.
orbital is the space around the nucleus where probability of finding an electron is maximum.
Yeah. What happened, Srivatsa? You didn't had your dinner yet?
I didn't have yet.
Oh, that's why your energy is low.
Yeah. That's why. Yeah.
Ah, okay. So coming to the subshells. So generally subshells is nothing but an orbital. Okay. So there
Yeah.
are 5 subshells S, P, D, and F. Okay. How many subshells are there? There are 4 subshells. Those are S, P, D, and F. Okay. Clear. Oh, hold on. Let's see.
Yes. Yeah.
File was done. Let me save this and
Yes.
so what are subshells? How many subshells I told you? Subshells are 4 in number. S, P, G, F. So in detail, we are going to learn about the subshells now. Okay. Coming to
Yeah.
the S subshell. S subshell. So S subshell is spherical in shape. Okay, it is spherical in shape. Shapes are very, very, very important. S subshell is spherical in shape. Okay. How many orbitals are present in subshell? So there is one orbital. In S subshell, how many orbitals are present? One orbital. In S subshell, how many orbitals are present? Please tell me. One
One.
orbital. Yeah. So each orbital have tendency to accommodate maximum 2 electrons. So as it is having one orbital, it can accommodate 2 electrons. Understand?
Yes.
Okay. Coming to the P subshell. The shape of P subshell is going to be dumbbell in shape. Okay, dumbbell in shape. You know what is dumbbell, right?
Yeah.
So it is dumbbell in shape. So how many orbitals this P subshell is going to have? 3 orbitals. As I told you, each orbital, like one orbital, accommodates 2 electrons. So as there are 3 orbitals, it accommodates 6 electrons. Understand?
Yeah.
So you can make a note here. One orbital is equal to 2 electrons. So one orbital can accommodate always 2 electrons. So based on the number of orbitals each subshell is having, so you can easily find out the electrons. Okay.
Yeah.
Okay. What is the next subshell after S? The next subshell is going to be D subshell. Okay, next subshell is going to be D subshell.
Yeah. Yeah.
D subshell. It is double dumbbell inch.
Speedy.
It is double dumbbell
Okay,
inch.
only.
Okay.
Three
So
only.
in D subshell, we can find 5 orbitals. How many orbitals are present in D subshell? 5 orbitals. If there are 5 orbitals in D subshell, can you tell me how many orbitals are there?
How many electrons are there? If there are like
Yeah.
5 orbitals, that means there'll be like 10 electrons.
Very good. Because each orbital can accommodate 2 electrons, so 5 orbitals, 10 electrons.
Each orbital can be like 2 electrons, right? So that's why.
Yeah. So last subshell is F subshell. So F subshell, its shape is going to be 4-4 dumbbell. 4-4 dumbbell. Okay, it has 7 orbitals. How many orbitals it is going to have?
7.
7 orbitals are present
First
in
one.
F.
Ma'am, I'll tell you, okay? So if there are like
Yeah, how many electrons?
if there are like how many subshells, it will be like F subshell, it will be like 4-fold double. So how many electrons will be like 7 orbitals you're saying, right? No. So it's like 14, ma'am.
So 14 electrons. So knowing this is very, very important, Srivatsa, because in learning electronic configuration, you are going to fill all the electrons in the orbitals. Okay.
Hmm.
So here we can make a table, final table overall. So the S subshell, table here. Subshell, shape,
Oh.
orbitals, electrons.
Yeah.
Okay.
Yeah.
So S subshell, we have like 4 subshells here. S, T, D, F. So what is the shape of S subshell, Srivatsa? What is the shape we discussed?
Spherical, ma'am.
Very good. S is spherical in shape. S spherical. Okay. And
Yeah.
T is dumbbell.
Perpendicular.
Okay. D is double dumbbell.
Very different type of hard. You know,
Yeah. F
different
is
types of.
4 dumbbell. Understand?
Yeah.
S is spherical. T is dumbbell. D is double dumbbell. F is 4 dumbbell. Now coming to the orbitals. How many orbitals are present in each subshell? So one,
So it's like
3,
one orbital, three, it's
see,
like
you know,
5, 7.
yeah. You know about the odd number order? Do you know about the odd number order?
Huh?
Odd number, order of odd numbers.
Yes, yes.
Tell me.
So one comes for like a spherical and three comes for like dumbbell and five
No,
comes
no,
for like.
I'm asking you what is the odd number order?
Oh, it's like sorry, 1, 3, 5, 7, 9 up to 11, 13, 15, 17, 19, any of them.
Yeah, same thing. You can see the same. That's the trick you can memorize. Odd number order. So S has 1, E has 3, D has 5, F has 7 odd. If you know orbitals, then it is easy to count electrons. Right? Can you tell me
Yeah.
electrons now? Orbitals.
2 electrons,
Very good. Next.
6
Hmm.
electrons, 10, 14, 10 and 14.
Clear? Understand about the like this is like normal discussion about the subshell, the number of orbitals, its shape, and the number of electrons. Clear so far, Srivatsa?
Yeah, good.
Okay. Now it's time to learn about the shapes of these. We mentioned spherical, dumbbell, double dumbbell, and four dumbbell. Now we are going to see that how they look, the structure, how they look. Okay.
Yeah, yeah,
So if you take about the S subshell,
yeah.
S subshell, what is the shape of S subshell? Srivatsa, it is spherical in shape, right?
Spherical, yes, sir. Absolutely.
Yeah. So in any axis, you can find electron in any axis. So the shape is going to be this. Okay. In X
Yeah,
axis, Y axis, Z axis. These are like 3D dimension, like 3 dimensional. And what is this called as? I told you, this is spherical, S subshell.
yes.
Okay. So S
Yeah,
subshell shape, it is spherical in shape.
yeah, yeah,
Understand?
yeah, yeah.
You're drowsy, Srivatsa.
Ah,
You're drowsy.
no.
Okay.
No, be active.
Okay. On like around 40 to 45 minutes. Okay. Just
Yeah,
bear for 40 to 45 minutes.
yeah,
Okay.
yeah.
Next, P subshell. We discussed that S is spherical. And how many orbitals are there? One. How it looks? It looks. This is the one orbital. It looks spherical in shape. When you come to the p subshells are how many? 3 orbitals. So what are those 3 orbitals? We discussed p subshell is having 3 orbitals. So what are those 3 orbitals? One is considered as p, another one py, another one pz. So these are the 3 orbitals of p. So what x, y, z means? You can see that the electron globe is found in x-axis. So let me draw for you. The shapes are also very important. Srivatsa,
Yeah.
X, Y, Z.
okay. So what is Px mean? X in the sense it indicates what is the shape of P subshell? It's dumbbell, right? So you can see dumbbell shape in case of X. Let's say I'm considering this as my X, Y, and Z. So in the X, I can find a lobe where I can find electrons.
Yeah.
Understand?
Yeah.
That's what Px means. Py means in Y you can
X, Y, Z.
find in Y you can find
It
electrons.
will come like that.
Yeah. When coming to the
And
Z,
I'll show you, ma'am. It will be
yeah,
like,
you
and it will be like this.
it is
X.
which axis, Srivatsa? Which axis I'm mentioned here?
Oh, sorry, it will be like, ma'am, look.
Is that Z?
It will be like, okay, Z axis, ma'am.
Mhm. So on the
I'll
Z axis, you can find a lobe. Yeah,
because it
very
used to
good.
be like on X, then Y, now Z.
Yeah, understand. So you
Yeah.
can see the important thing you have to know here is whatever the lobe you're drawing. So this lobe, whatever the lobe you're drawing on the axis. Can you see the axis, whether it is X, Y, or Z, doesn't matter. So on the axis, you're drawing a lobe, right? Yes or
Yeah.
no, Srivat? So you can see in
Yes.
PX,
Oh, sorry. Yes, I mean.
yeah. So in case of PX, PY, and PZ, you can see the lobes are shown on the axis. And all these are like dumbbells. So that's what it looks like a dumbbell. So the name is given as dumbbell. Okay, clear.
Yeah.
Please erase your work, Srivatsa. Next is D subshell. In D subshell, how many orbitals are there? What is the shape of D subshell, Srivatsa?
Maybe it's like a double shape. Okay.
Yes,
Oh, it's like,
double.
I'm sorry, double dumbbell.
Yeah. So you can see two dumbbells here in the shape. When you see the shape, you'll understand. So there are like two dumbbells here. So how many
Oh,
orbitals
sorry,
are
it's
there?
like five, ma'am.
Very good. So there are 5 orbitals. I told you to memorize like even number, sorry, odd number order. Okay,
It's
odd
like
number
odd number, ma'am.
1, 3, 5,
So it's
7.
like 13579.
Yeah, so 5 orbitals. So what are those 5 orbitals? One is dxy, another one dyz, next one dzx, next one dx square minus y square, next one dz square. Understand?
Yeah.
So these are like 5 orbitals you can find. Clear?
Yeah.
So let's see the shapes. In dxy, can you see the shape here, xy? XY in the sense it means in both the x-axis and y-axis. So this is in between the axis. in between x and y axis, you can find a load. In between
Double number, one mistake.
x and y axis, you can find a
Okay,
load.
okay.
That's what it is, a double dumbbell. And in y and z, in between y and z, you can find a load.
One and zero.
Oh, no, I know. So it's
Okay.
like, it'll be like for X, it'll be like this, and then for Y, it'll be like that, and then for like
Exactly.
Z, it'll
Yeah,
be
for
like
zx.
come
Yeah,
in the
in
right
between.
side. Now I know. So X will and Y, Z will be in the right side. Everything will be in the right side. So that will be from reverse Y, Z, X, 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 Y, Z.
Yeah, you can show any manner. You can show y, z, it doesn't
In the
matter.
front, I can show anything, but it will come from the reverse X, Y, Z,
Yeah.
or here.
So yeah, different. See the difference. This is our dxy, this is our dyz, and this is our dzx. Okay, so the difference what we can find here in case of p orbitals, you can find on the axis a lobe is present, isn't it? On the
Yeah.
axis. But when you consider this b in between the axis, in between the two axes, not here, we are not showing here. We are showing in between the axis. Understand?
Yeah.
So this is dxy, dyz, and dzx. So these are the shapes. And coming to the dx square and y square.
X square plus the 20.
Sorry.
When you take dx square minus y square and dz square. So x square minus y square it indicates that on the x-axis and y-axis you can find a loop. What? On the x-axis and y-axis. On. See the difference. This is in between the axis. This is on the axis. This is similar to the P subshell. So in case of these x square, this shape is like little different. Please see the
Hello.
shape.
Little bottle.
Okay. This shape is little different. Srivatsa, you okay?
Yeah.
What you did from morning today, Srivatsa?
What thing, man?
Ma'am, let him face his watch.
Yeah, sure, sure.
Watch his face, yeah.
You can wash your face,
What's
Srivatsa.
wrong?
Or else we can
I
sing a
washed in the
song.
bathroom already.
You did?
Yeah.
Okay.
Srivatsa, if
Yeah.
you did already, we can sing a song together.
Okay.
Okay?
Because
Okay,
I'm already.
you got smile on your face. That's good. Okay. Okay, clear with this, Srivatsa?
Yes.
So coming to the F subshell, we have discussed it is a 4-4 dumbbell, which is going to have 7 orbitals. So these shapes are not important. Just I like you should have an idea about the F subshell, its shape, how many orbitals it is having, and how many electrons are present. Here with this all the
Yeah.
shapes. Now we can learn about quantum numbers. I hope everything is clear. Let me explain you once again. What is orbit? Orbit is the circular path around the nucleus where electrons revolve. And coming to the orbital is the place where you can find electron. Okay. Now we have seen 4 types of subshells. S, P, D, F. Okay, what is S subshell? S subshell, like each one has a different name. Like based on the name, the letter is given. So names are not important for you. So S subshell is spherical in shape. P is dumbbell. D is double dumbbell. 4 is 4-4 dumbbell. Okay. So the number of orbitals are S has having 1 orbital, P 3 orbitals, D 5 orbitals, F 7 orbitals. Understand?
Yes, sure.
Okay. So number of electrons also we have seen. So you know, I think it's better if I make you to learn electronic configuration because you are tired today. Okay, that gives you some energy. Okay, so before that, we can see a Euler diagram, how it will look. 3s, 4s, 5s, 6s, 7s, 8s. So these are like orbitals. This is like S subshell. What one means? So you can see one indicates that it is in first orbit or first energy level. Two indicates second orbit or second energy level. So that's what two indicates. So 2p, 3p, 4p, 5p, 6p, 7p. So leave one at the top and bottom and start writing from here. 4p. After p, it is this 4d, 5d, 6d, 7d. Then you have 3d, 4d, 5d, 6d. Next you have 4f, 5. So what it means, you can see in the first level. This is first orbit. This is second orbit, third orbit, fourth orbit. So in each orbit, these are the levels. Okay. So I can give you a trick here. In the first orbit, you can find only S. In the second orbit, you can find S subshell and P subshell. Okay. In the third orbit, you can find S, P, and D subshell. In fourth orbit, S, P, D. So you can memorize like school. Next, it is public school.
In public school.
P and S. So next, DPS you have. So you can memorize like Delhi Public School.
Okay.
So the trend is very, very important, Srivatsa. And add any name F first. Till here, you have to memorize for 4F. So what do you say? Like what can we add for F? So for
For F,
DPS, we added like Delhi Public School for DPS. For F, what we can add? Which
for
means
F, we can add
Family Delhi Public School.
family
What do
public
you say?
school. Family public school.
Yeah, Family Delhi Public School. You can memorize in this way. So in the first orbit, you can see only one subshell. In the second orbit, you can see two subshells. In third orbit, you can see three. In fourth orbit, four. Okay. Now,
If
number of electrons these orbits can fill. Can you tell me in S subshell how many electrons you can fill? Srivatsa, how many electrons you can fill?
two, sorry, two.
Two electrons
And
you
in an
can
exception, I
fill.
can feel like
The
one
number of
obstacle, one obstacle, one obstacle.
One orbit.
One orbit will be equal to two electrons. And then two orbits will be equal
yeah,
to
in
like
S you can fill
four
two
electrons.
electrons. No, Srivatsan. I'm asking you in the first orbit, how many electrons you can fill? This
Like
is our first orbit.
two.
Very good. So
Two,
you can fill two electrons. In the second orbit, how many electrons you can
four.
fill? Uh-huh.
Sorry, the three. What's like, how is it three? It's not, it's two.
In second orbit,
Sorry,
what are present? S is present, P is present. In S, how many you can fill?
sorry, it's like three.
In S orbital, how many electrons you can fill? In S orbital, how many electrons you can fill, Srivatsa? Are you there?
Ma'am, sorry, I got
Yeah,
disconnected.
no problem. No problem.
Okay.
Okay. In second orbit, how many electrons you can still see? In the second orbit, what orbitals present? Tell me what
Yeah.
orbitals are present in second orbit?
So it's like so it's like a
What
okay.
subshells are present in second orbit, Srivatsa?
Two 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 electron.
2s and 2p, right? So S is
Yeah.
have one orbital. So one orbital in the sense two electrons. P is having
Four.
so it means
One orbit is go to two
overall
electron. Two orbits will be like two
overall
electrons. Three, four electrons. Three orbits will be like six.
yeah.
Ma'am, I told that only. Maybe you didn't hear. I said
So
like for two orbits, I said four electrons, and you didn't hear before we got disconnected.
yeah, you are you are correct. So actually that was not my question. In this, how many orbitals are second orbit and how many electrons you can fill? Okay.
Okay, now I understand. In
So
the
you
second one,
can
there is
use a
like
formula.
second two orbit.
Yeah. In the you can use a formula here which is 2 square. Okay. N stands for orbit number. So how many orbitals can be filled in how many electrons? So this formula is help to find number of electrons you can fill in an orbit. Okay. In the first
Yeah.
orbit. So what is n value? N value is orbit number. Let's say if I ask you number of electrons present in first orbit. So we can discuss all this. Number of electrons in first orbit. So which formula I told you to memorize? 2n squared. Right?
Yeah, two into n square.
And what is n? N stands for orbit number. Then what is orbit number?
One
In case
orbit
of
into
first
one.
Sorry, it's like one.
Two into one square.
So sorry,
yeah.
it's like
So
two
2
and
into
four.
1 square. So you can
It's like
accommodate
two.
only
Sorry, two.
Inside the box.
2 electrons in the first orbit. Okay. Next, number of electrons you can accommodate in the second orbit.
It's like four.
Oh, no.
No, sorry.
2 into
Number of
2
electrons, two
square.
into two to the power of two. So it's like four. Two square.
One four into two
2
later.
Sorry,
square
I'm
is
saying two into four. Two into four. Eight.
in third orbit.
Three into three square.
Two. Two n square is a formula.
2 into
Two
3,
into two into three square.
which is
Two
going
into
to be
18.
8. Understand? In this way, we generally use our understand.
Yeah.
So always in the first orbit you can fill 2. In the second orbit you can fill 8. In the third orbit you can fill 8, like 18. So this is the maximum limit. You can fill less than that, but not more than that. Understand? So like
Yeah.
you are there. Your capacity of eating chapatis is like 4. You can eat maximum 4. Okay, not more than 4. But you can eat 1, you can eat 2, the same thing.
Yeah.
Understand?
Yeah. Yeah.
Let's see each element and its electronic configuration now. If you take hydrogen, what is atomic number of hydrogen, Srivatsa?
It's one.
Very good. Atomic number is 1. We write element here. And then we write electronic configuration here. Okay, first element is hydrogen, you said. Okay. Now, how many electrons hydrogen is having, Srivatsa?
Electrons, right?
Mhm.
One, everything one.
1. Very good. Now, if atomic number is 2, then
It's like
element is
He.
He. So how many electrons it is having?
Of two-way.
Two only. Okay. If atomic number is 3, then element is
Li.
Li. How many electrons
Three,
Li
three,
is
three,
having?
three.
3 electrons. But we are writing electronic configuration here. Electronic configuration means that is arrangement of atoms, arrangement of electrons. So how we have to arrange these 3 electrons? I told you in the first orbit you can accommodate only 2, so not more than 2. So among 3, you
Yeah.
can fill 2 in first orbit, 1 in second orbit. Understand? You're getting? Among 3 electrons, you cannot fill 3 electrons in the first orbit because capacity of first orbit is only 2. So you are going to give 2 electrons to the first orbit and next electron goes to the second orbit. Now what is the capacity of second orbit, Srivatsa? See, what is the capacity of
Sorry.
8? So
8.
8.
8.
Yeah. So you can fill maximum 8, not more than that. Okay, let's see how it is. Electronic configuration is very, very important, Srivatsa. If atomic number is 3, then your electronic configuration is going to be 2, 1. Understand?
Yeah.
Tell me for
B.
element B for,
B for beryllium.
okay, electronic configuration is,
I'll tell you, it's like we don't say, okay. It's like 3 comma. Sorry. Of two comma 3 only.
we cannot make 3. In the first orbit, you can fill only 2.
2, so it's like 2
2,
2 comma 2.
2. Okay, overall 4. Understand?
Yeah.
Tell me for 5. 5 is going to be,
2 comma 3.
yeah, very good. Element is
Then it will be like BO.
BO for,
B only, B only.
B for
B for bag, ma'am.
bad,
Bag.
bad.
Oh,
What,
sorry.
Srivatsa?
Baran.
You are in chemistry class. Okay, B for boron. Next, 6.
Sorry. Ca.
C for cat.
No, for calcium.
C for
Oh, sorry,
calcium.
carbon.
Yeah, C. I thought you will be saying again cat. Okay. 6
Yeah.
is carbon. C. Now tell me
2 comma
electronic
4. 2 comma 4.
2 comma. Next one. Yeah, tell me next element is 7. Atomic number 7. Element
Sorry, element is like Ni.
Ni for
Nitrogen.
nitrogen
Sorry,
is
N
Ni.
for nitrogen.
Yeah, N for nitrogen. Electronic configuration
2 plus 5.
2
2 comma
comma 5.
5.
Yeah, 8.
Oops, sorry, next is O.
O for
O for oxygen.
owl. Oxygen. Okay. Electronic configuration
2 comma 6.
Ma'am,
very.
I
Yes,
think he's just telling that 2 comma 5. He's not realizing in the first orbit it has to go 2 electrons, and in the
Yeah,
second
yeah.
orbit it has to go
When it
6
comes
electrons.
like
Yeah,
yeah.
yeah,
When it comes like after 8, I'll explain that.
yeah, sure.
I know. It will come reverse.
Okay. Let you explain me what is reverse later. Okay.
Means in the sense if we put like 2 comma 7, no, it will not be like that. We have to put 7 comma 2.
Why 7 comma 2
Because it will
Srivatsa?
6. You should start from 6. So it will be like 6 comma 3, 6 comma 3.
Wait. This indicates first orbit electrons. This
So
indicates second orbit electrons. So first orbit can accommodate only 2 electrons.
Second,
So because of which it is fixed.
second
So
orbit can an orbit can like do how much? Can
how
do
many second orbit can accommodate? We calculated how many it can accommodate 8. So you can fill 8, not more than that. Understand?
yeah.
Atomic number 9 element is
Oh, sorry. FL,
Fl for
fluorine.
fluorine is Fl3 Vatsa.
Sorry, F.
F. Fluorine is F. Now tell me these how many electrons fluorine has? You tell me how many electrons fluorine has?
Configuration, you mean, right?
No. How many electrons fluorine has?
Sorry, it has like uh, no 9.
9 electrons. Very good, Srivatsa. 9. How you are going to fill 9 electrons in the energy levels that is in the orbit? In the first orbit among 9, how many electrons you can fill?
How many electrons?
How many among 9 electrons? How many electrons you can fill in the first orbit?
Oh, it's like okay. No. How many electrons is like
How many
um
electrons you can fill in the first orbit, Srivatsa?
sorry, 3.
See,
Maximum 2.
2. Okay. So among 9 electrons, how many you can fill in first orbit?
Sorry, it will be like 7, 8.
You're not getting my question. Among
No, no,
9
no, no,
electrons,
no. Ma'am. I mean, it will be like 7, comma 6.
just answer my question, please. Please tell me how many electrons you can fill in first orbit. How many electrons you can fill in first orbit, Srivatsa? How many you can fill in orbit? 2. So if fluorine has 9 electrons, you can fill only 2 in the first orbit. Can you see how I'm writing? 2 comma I'm
Yeah.
writing. So among 9, if I fill 2 electrons in the first orbit, then how many electrons are remain?
It will be like 7. 7.
Ah, 7 electrons are remain. So you are going to fill those 7 electrons. The second orbit. Understand?
Mm.
Is it clear?
Yeah.
So among 9 electrons of fluorine, you are filling 2 electrons in the first orbit and 7 electrons in the second orbit. So that the electronic configuration became 2 comma 7.
Yeah.
Understand?
Yeah.
Next, if atomic number is 10, element is
And sorry,
is it
Ne.
Ne? What Ne stands for, Srivatsa?
Neon. Sorry.
Very good. So neon has how many electrons?
Sorry, it is like it has like
Neon has how many?
sorry, it has like 10 electrons.
Very good. Among 10 electrons, how many you can fill in the first orbit?
In the first orbit, it will be like uh 2,
Hmm.
comma
Hmm.
8.
8. So overall 2 plus 8 gives you 10. Very good. Next atomic number is 11. So element of 11 atomic number is
Oops, sorry. Now it is like Na.
what Na stands for.
Sodium.
Very good. Now can you tell me electronic configuration? Please try. How many electrons are in sodium 3 Vasta?
Like they're like how many electrons is so 2 comma 9.
Okay, 2 comma 9. Is that correct?
Which is the last
10
where
seconds.
two, when will two end, ma'am? In the beginning. When will the next one start?
Yeah. 2 is in the beginning. Second, you can accommodate only 8, not
Yeah,
more
okay,
than
fine.
8.
Two is like in the
Maybe
beginning. When will two stop?
2 is in the
For which
beginning.
number? Yeah, two is
Right.
in the beginning and it will end up till like 12, right?
Yeah.
8. 8, right?
2 will be common everywhere.
Or everywhere. I thought it will end and
It
another number will
starts
come.
from helium. It starts from helium and it will be like overall.
Oh, two is
Okay.
common everywhere. Okay.
Yeah. If you fill 2 in the first orbit, then how many electrons are left in sodium?
9, 9, 9.
9. So how you are going to fill electrons? 9 electrons. How many electrons you can like you can fill in the second orbit? How many electrons you can fill in second orbit?
9 electron. Sir,
What is the
why I said,
maximum limit?
ma'am,
Maximum.
NA will have like 11 electrons.
Okay, Srivatsa, Na has 11. That's not our question. How these 11 electrons are arranged in a sodium?
2, comma 9 only.
2 comma 9, you cannot do that because second orbit capacity is 8. Then the other one
Oh,
goes to the
okay, okay.
next.
Oh, now I
You
understand.
cannot fill more than 8 in the second.
So 12
Understand?
will come like mg, and then it will come like 2
Like you are
comma
there.
9, 8 comma
Yeah.
2.
If like you have a box where you can fill only 8 chocolates in that. So you can fill only 8 chocolates because that capacity of that box is only 8. If you have like another extra chocolate, you will fill in the next box. The same thing here. So the capacity of second orbit is only 8 and the next electron goes into the next orbit. That is third orbit. So 2 comma 8 comma 1. Understand? So third orbit can accommodate how many electrons? Srivastava? It can accommodate 18 electrons. So you can fill 18. Okay.
Yeah.
Now tell me atomic number 12 is going to be
It's going to be like mg,
Mg for
magnesium.
very good. Now tell me how you are filling these 12 electrons. Tell me the pattern.
Yeah, so it's like 2 comma
2 comma
8 comma 2.
8 comma 2. Very good, Srivatsa. Next 13.
13 is like sorry. Oops, sorry, it is like Al
Alpha.
aluminium. Oops, sorry, Al for
Yeah. Electronic configuration. Be quick.
2 comma
2 comma
oops, sorry, 2 comma 8 comma 3.
8 comma 3. Perfect. Next element.
Oops, sorry, next element is like pH.
pH.
Oops, sorry, it will be like see here. From 14 I forgot.
14 is silicon, which is Si.
Silicon, okay.
Tell me electronic
2 comma
configuration.
8 comma 4.
15.
So it will be like this will come like pH.
This P for phosphorus.
pH.
Tell me electronic configuration.
2 comma 8 comma 5. What, daddy?
Next.
So it's like um, um 16 is like SU.
It is S for sulfur,
S
not
for
Su.
sulfur.
Yeah. 17.
If you forgot the electronic configuration, ma'am.
Yeah, we can do. Okay, you want to write? Please. Cell phone.
2,8,6.
So 17.
I'll tell, okay. So it's like CH, chlorine,
Cl.
Cl.
Electronic configuration.
No, it's like 2,8,7.
Very good. Next.
Sorry, it's like now. AG, argon,
Organ is AR.
AR.
Yeah.
So it's like 2,8,7. That's 8. 8, 8, 8.
Okay.
Ma'am,
Hmm.
ma'am. Ma'am,
Yeah, I'm here.
ma'am, ma'am. Right.
Yeah, I'm here. I'm here. 19. Atomic number 19 is. Hello.
Yes.
19 atomic number is 3 with
Sorry, it's like, sorry.
mm-hmm.
19 is like, from 19 it's like um,
Fast,
19 is,
fast. You can read
I'll
it
tell.
after telling this.
Ma'am, 19 is, I'll tell. 19 is, I'll read from number one, then I might get it. Hydrogen, helium,
Yeah.
lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, no, sodium, magnesium, aluminium, then 14 silicon, 15 phosphorus, 16 sulfur, something chlorine, 18 argon, 19. So like I read from 1 to 18, though I don't know.
Potassium.
Potassium and 20 will be like calcium. So potassium, PO.
Potassium. Yeah.
K,
So
sorry,
see
K, K,
here, 2
K,
comma 8
K.
comma 1. Yeah.
2
Okay.
comma 9 comma
Potassium
8
is
comma
8.
9.
See here, 2 comma 8 comma. No, you're writing 8 comma 1. So why it is 8 comma 1 is based on the octet rule, which you study in your higher classes. So 2 comma 8 comma 8 comma 1. Okay. So
Oh,
now
so it will come
the
like, oh my
capital
God,
is
it's like
2
I
comma
don't know.
8.
I don't know why it's like that. It should come like 2 comma 8 comma 9, I thought.
No. So based on the octet rule, you follow. Okay.
Yeah.
What is octet rule means whenever a particular element is having 8 electrons in its outermost shell, then it is going to be like very stable one. So having 8 electron is stable, so it doesn't want to make it 9. Because of that, it allows to go to the next level.
Yeah.
Okay, because of
Yeah.
octet rule. Clear, Srivatsa?
Yeah.
Okay, clear with the electronic configurations. In the next
Clear.
class,
No,
in the
man.
next class,
Man.
before coming, please memorize all these because we are going to learn the diagrammatic representation of all these electronic configurations. So it's
Okay,
very,
oh, sorry. Okay, ma'am. Okay, ma'am.
yeah, please memorize these well, electronic configurations. Okay,
Yeah.
okay, then we can meet in the
Good
next.
night, ma'am. Good night, ma'am. Good night.
Good
Bye.
night. Have a
See you in
great
next class.
night.
Good night. Bye.
Bye, Srivatsa.